Alright, in this video we are going to look at some graphs of quadratic functions, and we're going to find different pieces of information. The first thing that we are going to do is we're going to learn how to find the vertex given the graph. Then we'll look at something called the axis of symmetry. Then we're going to find the x and y intercepts, find the domain and the range, and then find either the maximum or minimum value. All right? So let's start with this first graph. And the first thing that I'm going to do is I'm going to go through all of the graphs. I'm going to find the vertex for each of the graphs. All right? So the vertex is the point where the graph turns around. And so this bottom point right here is the vertex for this graph. Now notice from the origin it goes over 3 and up 1. And so my vertex will be 3, 1. Right? This one, looking at, again, this point where it turns around, and again, it's a bottom point. And notice that it goes over 1 and down 1, 2, 3, 4. So over 1, down 4. And so the vertex here is over 1, down 4. Now looking at this one, again, the point where it turns around is this bottom point, and it goes over 1, 2, but it's in the negative direction, and down 1. And oh, I'm sorry, and this should be negative 4. Because it's going down 4. All right, so this one goes over negative 2 and down 1. So my vertex is going to be negative 2, negative 1. Now, notice this one, it turns around here at this point right here. And so my vertex here is over negative 2, up 1, 2, 3, 4. All right? And notice that this one, because it's going upside down, this is the point where it reaches its top. And we'll talk about that in a little while. And then here, this point is my vertex. And so it's over a positive 2 and down 2. So my vertex for this one is going to be over positive 2, down 2. Excuse me. All right. Now, the next thing that I want to look at is my axis of symmetry. Now, when I am looking at a regular parabola, and this is why I left this space blank here, if I'm looking at one of my parent graphs, it looks like this. And notice that we talked about the axis of symmetry, although we didn't really call it that, but we said that this graph was symmetric about the y-axis, all right? Because this part of it looks like the same as this part of it. And so on this one, notice that my vertex is the origin, because it starts here at the origin. Now, this axis of symmetry is this line that runs down through the graph and goes through the vertex. And so the axis of symmetry for this one is the x-axis. And the equation for this vertical line is x equals 0. Because remember, on all of my points on my graph, this would be the point 0, 0. This would be the point 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, negative 1, 0, negative 2. So on this line, all of my values for my x-coordinate are 0. Now, looking at this one, my axis of symmetry also goes through my vertex. So it looks like this. All right, and notice on this one that my vertex is 3, 1, and I'm going to go ahead and write that on the graph. So when I'm looking at my axis of symmetry on my graph, it always goes through the vertex, and it's always, see how this one is x equals 0? Well, the axis of symmetry will always be x is equal to, and it'll always be the x-coordinate of my vertex. Because this would be 3, 0, 3, 1, 3, 2, 3, 3, 3, negative 1, 3, negative 2, and so forth and so on. So my axis of symmetry here is x is equal to 3, because all of my x values on this line would be 3. And again, notice how you have that symmetry, how this part of the graph and this part of the graph look like mirror images. Okay? On this one, we said that the vertex was 1, negative 4. All right? And so my axis of symmetry on this one will be x equals 1, because this would be the line right here, and on all of these x values, my x would be 1. Now this one, the vertex is the point negative 2, negative 1. And so now you see if you can figure out what the axis of symmetry is. So in this one, my x-coordinate of my vertex is negative 2. So my axis of symmetry will be x is equal to negative 2. All right, same thing here. Try it on your own. And so again, it's this vertical line that runs through the vertex, and since this is the coordinates of this point is negative 2, positive 4, then this one will be the x will always equal negative 2. And then the last one here, the coordinate here is 2, negative 2. And so this line will be x is equal to 2. So my axis of symmetry will be x equals 2, because that is my x-coordinate. All right, now let's talk about the domain and the range for these. Now remember, the domain is the possible x values. So notice the x values always go from left to right. So notice that this arrow goes to the left and this arrow goes to the right. So my domain will always be all real numbers. All right? So for all of my parabolas, if it's a full parabola, the domain will be all real numbers. But notice that my range is not. My range is my possible y values. So if I go, and remember, it goes from bottom to top. So domain is left to right, and range is bottom to top. Okay? So going from bottom to top, notice that I don't hit any graph until I get to my vertex. And that y-coordinate, because remember when we're dealing with the vertex, that y-coordinate is going to be 1. and it's the y-coordinate of my vertex. All right, so it starts at 1, and then notice both arrows go up, so both of them go to infinity. And this one will always be the y-coordinate of the vertex, and it'll always be a bracket. All right? Now, while we're talking about, well, let's go through all of them, and we'll do domains and ranges on all of them. All right, so this one, again, this goes to the left, this goes to the right. So I have one arrow going to the left, one arrow going to the right, and so my domain, all real numbers. The range on this one, going from bottom to top, notice I don't hit the graph until I get to my vertex. And this y-coordinate here is -4. And so it starts at -4 and it goes to infinity. All right, same thing here. Domain goes to the left, goes to the right. And so it's going to be always all real numbers. But my range, no graph down here. Okay, so try this one on your own, see if you can figure out the range. So starting down here, it doesn't hit the graph until my y-coordinate is -1. So remember, the range is always dealing with the y-coordinates, not the x-coordinates. All right, this last one, the domain, again, all real numbers. And the range here, and this, all real numbers, you can write either like this, or you can write from -infinity to infinity. And again, parentheses always on infinity, never brackets on infinity, because you can never reach infinity. All right, but the range, notice that both of the arrows on this one point down. So it actually starts at -infinity. And then the graph, I have graph all the way here until I get to this y-coordinate of 4. So you see how important it is to put this coordinate on your graph. Go ahead and draw the vertex, write down the coordinate for the vertex on the graph. All right, because it tells you your axis of symmetry, it tells you your domain and your range, and we're going to talk about more things that it tells you as well. On this one, the domain, again, both arrows are pointing down. So that means it goes all the way down to -infinity. So it starts, and again, you always go bottom to top. So it starts at -infinity, and it goes up to this y-coordinate, which is -2. And again, always a bracket on the coordinate, but a parenthesis on the infinity or -infinity. Now, this one's our parent graph, and we already looked at the domain and range on this one. The domain, all real numbers, and the range is from, again, nothing down here until I get to this point 0, 0, and my y-coordinate is 0. So it's 0 to infinity because both of the arrows go up. All right? So that's how you do domain and range on your graph. Now, the next thing that I want to talk about is either minimum or maximum values. All right? So, when I showed you these graphs, when I first started talking about the vertex, I said, look at this one. It reaches its bottom. So the bottom value, when it reaches a bottom value, that's the lowest that it goes. So this one would be a minimum value. So they'll ask, is it a minimum or is it a maximum? And this one is a minimum because it reaches a bottom. And the minimum value that it reaches is, again, the y-coordinate of your vertex. So this would be 1. So the minimum value that it goes, the lowest that this graph goes is 1. All right? The lowest, that this one also is a minimum. And the lowest that it goes is the y-coordinate. See, all of these points here, if I look at the x and y coordinates, the y coordinates are always going to be bigger than -4. So the lowest that it goes is -4. Same thing here is a minimum because it's the lowest value. And the lowest that it goes is the y-coordinate here is -1. All right, but notice that this one gives you a top value, and its top value is 4. So this gives you a maximum value, and its maximum value is 4 because the y-coordinate of your vertex is 4. This one also, see how it's upside down, and so it reaches a top here. Okay, and so it also reaches a maximum, and its maximum value is -2. All right, because the highest that it goes is -2. All the other y-coordinates will be less than -2. And then this one is a right side up parabola, so notice it reaches a bottom value. So this one is going to be a minimum. And its minimum value is the y-coordinate of the vertex, which would be 0. All right, so that's either maximums or minimums. Now let's talk about where it's increasing and where it's decreasing. So remember, on these, if it goes from left to right and it's going down, then it's decreasing. If going from left to right is going up, then it's increasing. So notice here it would be decreasing because it's going down, but then at the vertex it turns around and it goes back up. So it's decreasing here and it's increasing here. So when I'm talking about increasing and decreasing, I always use my x coordinates. Okay, so domain is x coordinates, range is y coordinates, minimum or maximum y coordinates, but with increasing and decreasing, it's always going to be the x coordinates of the vertex that you're using. So this one is increasing, increasing on part of the graph, and it's decreasing on part of the graph. All right, and so let's look. So this one is decreasing starting out here because I'm looking at my x coordinates. So starting at -infinity until I get to the x coordinate of 3. So it's decreasing from -infinity to 3, and then it starts to increase. So from 3 to infinity. All right. This one also is decreasing till it gets to its vertex. So where is it increasing and where is it decreasing? So it's decreasing from my x-coordinates from -infinity until I get to the x is 1. So from -infinity to 1, and then it starts to increase from 1 to infinity. Now remember, when you're doing increasing and decreasing, what you're looking at is you're saying, where is it going down, where is it going up, going from left to right. So remember, these are always going to be parentheses on these ones and on the infinities, because on the at 1 is where it's turning around. So it's not decreasing or increasing at 1, that's where it's turning around. Okay, so this one, where is it increasing and where is it decreasing? So let's see, from here it's going down. So on my x-axis it starts at -infinity and it's decreasing till I get to -2, And remember, these are always my x coordinates. And then starting at -2, then it starts to increase. And it increases all the way to infinity. Now this one's different because it's upside down. So this one is, it's just going to ask, where is it increasing? Where is it decreasing? All right, so this one, notice it's going up to start with. So starting over here at -infinity, and it goes until I get to the x equal to -2. And then it's decreasing from -2 to infinity. Okay, so all along here it's going down. All right, this one, where is it increasing and where is it decreasing? So try this one on your own, see if you can get it. So this one starts out increasing. So it starts at -infinity and it's increasing until I get to x is equal to 2. And then it starts to go down. So it starts at 2 and goes to infinity, and it goes down all the way to where x is infinity. Notice the y is going to -infinity, but the x is going to infinity. And then this one starts out, so again, where is it increasing and where is it decreasing? And this one starts out decreasing, so starting where x is -infinity and going to where x is infinity. So from -infinity to where the x is 0, it's decreasing, and then it starts to increase at 0, and then it goes all the way to infinity. All right, so remember, domain and increasing or decreasing, you're looking at your x-axis, and range and either maximum or minimum, you're looking at your y-axis. These are the only two that you ever look at your y-axis or your y-coordinate. All right? Now, last thing is they want you to find y-intercepts and x-intercepts. All right? So y-intercepts, let's start with the y-intercept. The y-intercept is where it hits the y-axis. So let's look. Starting at my origin, let's count up and see how far up it goes to my y-axis. 1, 2, 3, 4, 5, 6, 7. So that's 7 on my y-axis. But I have to, when I give my y-intercept, I have to give it as a point. And remember, the y-intercept is where x is equal to 0. So this would be the point 0, 7. Okay? This one, the y-intercept will be, well, let's see, it hits right here. So this would be 1, 2, 3, -3. So it would be 0, -3. This one hits at, it looks like 1, 2, 3. It looks like it hits right here. I wasn't very careful when I drew it, but it hits at where the y-coordinate is 3. So the y-intercept here would be 0, 3. The y-intercept here, let's count, 1, 2, 3, 4, 5, 6, 7, 8. So that's -8. And again, the x is always 0. And then this one hits here, so